Hello everyone. My name is Paris Black, and welcome to my final case study presentation. Today, we're diving into something that affects all of us, stress, but in a way that most people never think about. Because, yes, prolonged stress can actually shrink your brain, and let's talk about why. So, to start, think about a time when life just felt like it was too much. You have assignments, work, family, everything is hitting you all at one time. What we don't always realize is that our brain isn't just overwhelmed emotionally, it's reacting physically. The hippocampus, which helps us remember things and regulate emotions, is especially sensitive to stress. When cortisol stays high for too long, this structure actually begins to shrink. And that's why this topic is so important in biological psychology. It shows how daily experiences have real, measurable effects on the brain. My main argument is that chronic stress disrupts the brain's natural balance. It damages neurons in the hippocampus, reduces neuroplasticity, and makes it harder for us to manage memory and emotion. These changes lay the foundation for disorders like depression, PTSD, and anxiety. So, this is a perfect example on how biological psychology connects to life experiences, which affects biological changes in the body, which overall affects behavior. So, the guiding question in this entire case study is how does chronic stress alter the hippocampus, and what does that mean for mental health? Across multiple studies, researchers found that chronic stress constantly activates the HPA axis, which keeps cortisol levels high. Over time, this leads to reduced neurogenesis, damaged dendrites, and lower levels of BDNF, which is like a fertilizer for your neurons. Authors like Edwin, Brimmer, and Mondolilli all show that constant evidence that people exposed to long-term stress often have a smaller hippocampal volume and difficulty with memory and emotional regulation. When researchers looked at brain scans, the patterns were obvious. More stress equals a smaller hippocampus. A smaller hippocampus equals poor memory and higher vulnerability to mood disorders. So, chronic stress isn't just a feeling, it's a physical, structural change in the brain, and one that affects how we function on a day to day basis. There are two main models that explain what's going on here. First, you have the HPA axis. When it's activated repeatedly, cortisol stays high and starts damaging hippocampal neurons. Second, the allostatic load model, which shows how long term stress creates wear and tear on the brain and the body. And because the hippocampus helps regulate stress, once it weakens, the cycle gets worse. More cortisol equals more damage. When we applied these theories to real world scenarios like PTSD and major depression, we see the same thing. Smaller hippocampal volume and difficulty with emotions and memory. From a cognitive angle, stress affects our memory. From a biological angle, it alters our brain structure. And from a clinical angle, it shows why interventions that reduce cortisol or boost neuroplasticity can also be helpful. This case demonstrates how environmental stress and biological processes ultimately affect behavior. So next we have our visuals. In figure one, you have the allostatic load model, which shows how repeated stress leads to biological strain. Figure two demonstrates how a larger hippocampus correlates with better memory and performance. Figure three demonstrates how lower BDNF is often caused by stress and is linked to smaller hippocampal volume. Together, all of these show that stress physically reshapes the brain in predictable ways. So the peer feedback, I improved this project after getting feedback from my classmates. They suggested adding more depth to the future research section and breaking up some of the heavier content that I had in the slides. So I added more clear examples of how potential interventions and I reorganized the slides to make the information easier to digest for my audience. So we have our future directions, and the future directions in this case study is actually really promising. Exercise boosts, BDNF, and stimulants promote hippocampal growth. You have mindfulness that reduces cortisol and strengthens emotional regulation, hormonal treatments that may help protect hippocampal tissue, early intervention programs that can reduce long term vulnerability to stress, and long term imaging studies that can show how healing happens over time. So while chronic stress can change the brain, recovery is absolutely possible, and we love that. So, finally, our conclusion to wrap things up, chronic stress elevates cortisol, lowers BDNF, and weakens the hippocampus. This affects memory, emotional balance, and overall mental health. But understanding this connection gives us better strategies for prevention, treatment, and recovery. This case study shows how biological psychology connects the brain, environment, and behavior, giving us a deeper understanding of how stress affects us overall. The next slide, I have my references. So I had 10 references listed all right here in APA format. So that is the end of my final case study presentation. Please email me if you have any questions and or concerns, and thank you so much.